Good afternoon, ma'am. I am J. Grant Kumar from CSM Department of P section from third year. Today I am presenting a CA2 assignment of the Natural Language Processing subject NLP. So the topic name is Types of Neural Networks. Types of Neural Networks. So first we can learn about Introduction to Neural Networks. Neural networks are computational models inspired by the human brain structure and function. So they are designed to recognize patterns and solve complex problems through interconnected layers of nodes. And next, there are different types of neural networks are suited for various applications in machine learning and artificial intelligence. So in the next slide, feed forward neural networks. The simplest type of neural networks where information flows in only one direction. So here we can see that the picture of the neural networks of the feed forwarding. So in this picture, neural network where information flows in only one direction, composed of input hidden and output layers with no cycles or loops. So commonly it is used for basic classification and regression task. And next, convolution neural networks. It is simply called as CNNs. So here we can learn how the specialized for processing grid-like data such as images and videos. We can also utilize convolutional layers to automatically detect features like edges and textures. And next, widely applied in image recognition, object detection and computer vision tasks. So it is the picture of the understanding of convolutional neural networks, CNNs. And next, recurrent neural networks. It is also simply called as RNNs, designed to handle sequential data by incorporating loops within the network, capable of maintaining here, so capable of maintaining information across time steps, making them suitable for language modeling and often used in speech recognition, language translation and time series prediction. So recurrent neural networks, it is shown as the figure. Simply it is the example pic of the recurrent neural networks. So it is called as neural networks which are breaking. It will recurrent the all capable of maintaining information across time steps. So there are time steps which is used in speech recognition, language translation and time series prediction. And next, long short term memory networks. It is also called as LSTM in the shortcut. So a type of RNN means we can know recurrent neural networks. So a type of RNN that addresses the vanishing gradient problem in traditional RNNs. It is also uses special gating mechanisms to preserve information over longer sequences. So it is commonly employed in natural language processing and sequence prediction tasks. And next, gated recurrent units. It is simply called as GRUs, which is in the topic of the neural networks, and a simplified version of LSTMs. LSTMs is long short term memory. So in a simplified version of LSTMs with fewer parameters for fasting training and incorporate gating mechanisms to control information flow effectively. And next, it is suitable for applications requiring sequence modeling with limited computational resources. So in this gated recurrent units, it is a combination of simple version of the long short term memories, which is also called as LSTMs, with fewer parameters for faster training. So for suitable applications requiring sequence modeling with unlimited computational resources is the key point of the gated recurrent units. And next, autoencoders. So here, the unsupervised neural networks used for data compression and feature learning. So consist of encoder and decoder parts that reconstruct the input data. And next, applied in anomaly detection, image designation and dimensional reduction. So in the autoencoders, there are two types of encoders, which is first one is encoder and next one is decoder. So the consist of encoder and decoder parts that reconnect the input data of the autoencoders. So in the encoders parts, we can handle the only encoders, but in the autoencoders we cannot have to handle that encoders. It's automatically consist of encoder and decoder parts which can reconstruct the input data. And next, generative adversarial networks. It is also called as GANs. So it is the consist of two neural networks competing against each other, generator and discriminator. So the generator creates realistic data samples while the discriminator evaluates them. It is also used in image synthesis, data augmentation, and artistic style transfer. So in the generative adversarial network, the generator creates realistic data samples and the discriminator evaluates them. So the generator and descriptor are the two neural networks which is under the generative adversarial networks. And next, transformer networks utilize attention mechanisms to weight the importance of different input elements and excel at modeling long range dependencies in sequential data. And next, the foundation of many state of the art models in natural language processing such as GPT. So this is the slide of the conclusion and future trends of my topic, neural network. So the conclusion is neural network architecture continues to evolve, improving performance and efficiency. And next, hybrid models combining different types of increasingly common for complex tasks. And next, ongoing research aims to develop more explainable and scalable and energy efficient neural networks. So this is the conclusion of this slide. So thank you, ma'am.